All right, it's your man Jimmy Chan. Let's try this for the third time. So I'm gonna go through some of the problems that are combined with both classes. So one of the things I'm gonna throw out here is that it's amazing to me that it seems to me that none of us, or most of us, do not like to go back to the notes. That's number one. Number two, would rather ask for questions on lab work 6 than the other lab works, so that you can have practice on lab work 6, but you rather get the answer to lab work 6 so it's done. Good news for me is I can actually grade on neatness now. So basically your lab work 6 is almost going to be totally done. So now I can grade on the neatness of it. And if it's messy, then I can start taking off points. So this is perfect. I love it. All right, so let's talk about some of the problems that were done today in both classes. So we're going to start off in no particular order, and then I'll get into the lab work 4 to 5 and 6. And I don't know if you guys know this, but all the lab work solutions are in your announcements as well. All right, so let's get started. So the first one, I should probably label them, is probably a good idea. All right, so it gives you P of x is equal to negative 5x squared plus 6x. So I want you to find P of negative 2. So to do this, I have to plug in negative 2 in for x. So P of negative 2 is going to equal to negative 5 times negative 2 squared plus 6 times negative 2. So the first thing I have to do is making sure that I raise it to the power first. All right. So this way I have negative 5 times 4 plus 6 times negative 2. So this is going to give me negative 20 plus a negative 12. So it's going to give me, so P of negative 2 is going to give me a negative 32. There we go. That's the first one. All right. Next. That one's done. So you guys keep on asking difference quotients. So I would just keep on doing them. It's no big deal. All right, so f of x is equal to, actually, let me do this. So this is asking for the difference quotient. Okay. So f of x is equal to negative 2x squared plus 2x minus 3. And don't forget the difference quotient was f of x plus h minus f of x all over h. So the f of x is already done. It's right there. So I need to find f of x plus h. So that's going to equal to negative 2 times x plus h squared plus 2 times x plus h minus 3. All right, so this means that I have to FOIL or double distribute this, and I'm going to have to distribute this. Okay, so that means I have a negative 2, and this is going to be an x squared plus 2xh plus h squared plus 2x plus 2h minus 3. So that means f of x plus h is equal to negative 2x squared minus 4xh minus 2h squared plus 2x plus 2h minus 3. Okey doke. So all I'm going to do is plug that red expression in for f of x plus h, and then minus the f of x. and then put it over h. So let's go ahead and do that. All right. So f of x plus h, so negative 2x squared minus 4xh minus 2h squared plus 2x plus 2h minus 3. And the minus, I'm negating, don't forget that because of this, I'm negating that whole thing, right? So now it's going to be plus 2x squared minus 2x plus 3. And this is all over h. Okay? So if you notice, let's use other colors here. Negative 2x squared, positive 2x squared goes away. Positive 2x minus 2x. Negative 3, positive 3. Okay, those all go away. So what do I have left? I now have left a negative 4xh minus 2h squared plus 2h all over h. Now, I can pull a GCF out of the top ones of h, so which is going to cancel with the bottom h. So all I have left is a negative 4x minus 2h plus 2. So there goes my answer right there. Okay, awesome. Next one. That one's done. Okay. Next one is another difference quotient. Let me see, what number are we on? 3. All right, so number 3. So this is going to be a difference quotient again. However, f of x is 12 over x. Okay? So, again, the difference quotient is f of x plus h minus f of x all over h. So I need to find f of x plus h. That's going to be 12 over x plus h. Okay? All right, so let's just plug it in. So here's the difference between the two. When it's given this right here, the beginning is a little busier, a little bit more work, but the end of it is pretty quick. With these type of questions here, the beginning is pretty easy, right? I didn't have to FOIL anything. I didn't have to distribute anything. However, the work towards the end is now going to be a little more difficult. So it's either heavy in the beginning or heavy at the end. So either way, it's still going to be the same. So if I plug this in, it's going to be 12 over x plus h minus 12 over x. So, I'm sorry, let me finish this part. All over h. So you guys saw this in 1033 before. This is called a complex fraction, okay? Where it's a fraction really over a fraction, because I can do this, right? I'm sorry, not that. I can do this. So it's a fraction over a fraction. And the way we did those is we got the top fraction to be one single fraction, the bottom fraction to be a single fraction, and then we divided fractions, which is copy, change, flip, okay? So again, what do they have that I don't have, right? That's what the question becomes. So let me use green, that's probably a good idea. So the red equation is missing an x. The right equation is missing an x plus h. And x plus h is two different things, okay? So don't think that you can just add an h top and bottom. It does not work that way, all right? So once I have that, if you notice, so if you look at the denominator right now, that denominator and that denominator are exactly the same, x times x plus h. So that means I can add or subtract the top and keep the bottom. So the top there is going to be a 12x minus 12 times x plus h over x times x plus h all over h, okay? So I didn't finish this all the way. Reason because I have to distribute that negative 12. So I have a 12x minus 12x minus 12h over x times x plus h all over just h. Okay, so if you notice that these two right here gets to cancel each other out. So I'm left with a negative 12h over x times x plus h all over h. So this is where I would copy. So it's a single fraction over a single fraction. So here's where I can copy, change, flip. I copy the first fraction, which is negative 12h over x times x plus h. I'm going to change, let me see here. I'm going to change this division sign into multiplication. And then I'm going to change the h and flip it. So I'm going to flip the h. So h is typically h over 1. So if I flip it, it's 1 over h. And if you notice that the h cancels with the h. So now I'm left with negative 12 over x times x plus h. And that would be my answer. Ta-da. Okay? So hopefully that helps. And that was number 3. So I'm on number 4. All right. So that problem is done. All right. So we're asking me to evaluate a couple of things here. So it was given f of x is equal to 2x minus 3, and g of x is equal to x plus 3 over 2. So it wants me to find f of g of x. So this is just telling me to find the f of x plus 3 over 2. So in other words, plug g of x into f of x. So that's going to be 2. Let me do this also. Let's call this red. So that means I got to call this red. So that means this is going to be times x plus 3 over 2 minus 3. Okay, this way you can see where I put the x plus 3 over 2 into f of x. So this is going to equal now to, the 2 is going to reduce. So I'm left with x plus 3 minus 3. So that's going to equal to x. Okay. And then it asks for g of f of x, which means that I'm going to do g of, the f of x, which is 2x minus 3. So I'm plugging in the f of x into g of x. So that's going to equal to two x minus 3 plus 3 all over 2. So that's going to equal to 2x over 2, which is again equal to just the x, because the positive 3 and negative 3 cancel each other out, so I'm left with the 2x. Okay? And then the next two parts is that it wanted me to find f of g of 2. Okay, so let's plug that in. So in other words, this is telling me that I gotta find g of 2. All right, and g of 2 is to plug 2 into the g function. The g function is x plus 3 over 2. So this is going to be a 2 plus 3 over 2. So g of 2 is 5 over 2. So that means now I got to find f of 5 over 2. So now I got to put in 5/2 into f. Okay, so that is going to be a 2 times 5/2 minus 3. Well, again, the 2 cancels out, so I'm left with 5 minus 3, which is equal to 2. And then it wants me to find g of f of 2. So first I got to find f of 2, which is throwing 2 into the f function. So that would be a 2 times 2 minus 3. So that's going to equal to 4 minus 3, so that's going to equal to 1. So now I got to find g of 1. So that is going to equal to, the g of x is 1 plus 3 all over 2, right? Yep. All right, so that's going to equal to 4/2, which is equal to 2 as well. So all the first part means right here with the f of x and the f of g of x and the g of f of x, since these two are the same, that means they are inverses of each other. And if you notice that even with the f of g of 2 and the g of f of 2, that result is going to be the same as well. So there goes that problem, and that was number 4. Okay. All right. Next problem. Oh, another difference quotient. This difference quotient says f of x is equal to x squared plus 3x minus 5. And so again, difference quotient is f of x plus h minus f of x all over h. So I need to find f of x plus h, which is equal to x plus h squared plus 3 times x plus h minus 5. Okay, so I got FOIL and distribute. So now I have x squared plus 2xh plus h squared plus 3x plus 3h minus 5. Okay, so I'm going to plug the red in for red, the black in for black. So in case if you didn't understand how the signs flipped over with this one here, I'll show you that as well. So here we go. So I got to write down the f of x plus h, which is x squared plus 2xh plus h squared plus 3x plus 3h minus 5 minus x squared plus 3x minus 5 all over h. So now I have x squared plus 2xh plus h squared plus 3x plus 3h minus 5 minus x squared minus 3x plus 5 all over h. Okay, so what do you notice? I notice that x squared and negative x squared. I notice positive 3x and negative 3x. And I also notice negative 5 and positive 5. So now I'm down to 2xh plus h squared plus 3h all over h. Now, if you don't understand about the h canceling out, here we go. The GCF up top is h, leaving me with 2x plus h plus 3 over h. Okay, notice how the h cancels out. So I'm now just left with, 2x plus h plus 3. And there is my answer. All right. Let me see here. All right, so that's number 4. Now I'm on to number 5. So number 5 says, find the inverse of f of x is equal to 6x plus 1 over x minus 2. So to find inverse, number 1, we replace the f of x with y, right? Then we're going to switch x and y. Okay, so now we get to solve for y again. So number 1, I would put parentheses around here and around here. And what I would do is multiply both sides by y minus 2. So let me show you that. So here's x is equal to 6y plus 1 over y minus 2. So I'm going to multiply both sides by y minus 2. And what will happen is that these will cancel. So I'm left with x times y minus 2, and that's going to equal to 6y plus 1. Okay, so let me distribute. So I got xy minus 2x is equal to 6y plus 1. I believe I did something like this in the notes, and I said, well, my goal is to solve for y, so I want to get y's on the one side. So if I bring the 6y over, I'm going to have xy minus 6y. So that means I got to bring that negative 2x over to the other side. So that's going to become a positive 2x plus 1. I'm going to take out the GCF of y, which will leave me with x minus 6 is equal to 2x plus 1. Then I can divide this off. So now y is going to equal to 2x plus 1 over x minus 6. And there you go. All right, so now, this was number 5, so I'm on number 6. So this is to find domain of f plus g. So my f of x is equal to 6x plus 1 all over 2, and g of x is equal to 2 over x minus 2. So all f plus g of x means is to take the f of x and add it to g of x. So that means I have 6x plus 1 over 2 plus 2 over x minus 2. So if it's only asking for domain, I don't really actually have to add them. It is not really necessary, right? Because if I was to add them, all I do is say, okay, what do they have that I don't have, right? So I would multiply this by x minus 2 and multiply this by 2 and then go from there. So my bottom will be 2 times x minus 2. So all I got to be careful of is that what's going to happen to the denominator, because I only have fractions here, right? So with fractions, is that I can't have zeros in the denominator, right? So that means my x minus 2 cannot equal to 0. So that means x cannot equal to 2, just like solving for x. So x cannot equal to 2, but it can be anything else but 2. Okay? So if I was to draw this as a number line, let me do it this way. If I was to draw this as a number line, so let's say that's my number line and here is 2. My domain would look something like this. Let me use a different color here. I'll use red. So here's, oops. So here's my number. Here's my thing here, except the only thing I can't have is 2. So I can have anything else but 2. So that means I'm going from negative infinity to positive infinity, but I can't have 2. All right? So that means my domain would be negative infinity to 2, but not including 2, union with 2, but not including 2, all the way to positive infinity. So that would be my domain. And only because I can't have a zero in the denominator, okay? And you, like I said, you don't really have to finish this problem. You just gotta look at it going, okay, it's 2 fractions added together. So that means the left fraction, there's no x values that will make that denominator 0. The right fraction can become 0, right, in the denominator. And that is when x is equal to 2. So that's the only thing I can't have there. I can have anything else, okay? So there's that problem right there. And on to 7. All right. Another difference quotient here. So this one says f of x is equal to x squared minus 4x plus 3. So again, my difference quotient is f of x plus h minus f of x all over h. So that means I gotta find f of x plus h, which is x plus h squared minus 4 times x plus h plus 3. Okay, so I got a FOIL. X squared plus 2xh plus h squared minus 4x minus 4h plus 3. All right, so I'm plugging the red in for red and then minus the f of x. So here we go, x squared plus 2xh plus h squared minus 4x minus 4h plus 3 minus x squared minus 4x plus 3 all over h. All right, so that means top I have x squared plus 2x xh plus h squared minus 4x minus 4h plus 3 minus x squared plus 4x minus 3 all over h. So again, what happens? X squared, negative x squared, negative 4x, positive 4x, and positive 3, negative 3. So now I'm left with 2xh plus h squared minus 4h over h. GCF h on top, which cancels with the h on the bottom, so I'm left with 2x plus h minus 4. And there is my answer. All right. On to number 8. That one's done. So this one is to find the domain of g of x is equal to 1 over the square root of x minus 3. Okay? So two things here. First of all, fraction. The bottom, or the denominator, cannot equal to 0. Second thing, square root. Cannot take the square root of a negative number, right? So I can't take a square root of a negative number, and the bottom can't be 0. So typically what I would do is take this part right here, and let's choose another color. Let's go purple. All right, so I would say x minus 3 has to be greater than or equal to 0, right? However, that would take care of the square root part, okay? So this would do the greater than or equal to 0, right? Which is not negative, right? So, but the issue is that because it's on the denominator of the fraction, I can't even have it equal to 0. Because if it was equal to 0, square root of 0 is 0. So I'll have 1 over 0, which is a fraction that is actually undefined. So what I want to do is take the equals away. Oops. All right. And just leaving with just the greater than. Okay. I can't have it equal to 0. Okay. So if I solve this, that means x has to be greater than 3. So if x is greater than 3, that means it's going from 3 to infinity, but not including 3. So I'll have to be 3 to infinity, and that would be my domain. Again, if I did use 3, if it was like a typical radical, I would have 1 over square root of 3 minus 3, which is 1 over the square root of 0, which is 1 over 0, which is undefined. Okay? So that would be no good. That's why you can't include 3. So therefore, this is my answer right here for the domain. All right? All right, on to number 9. So it wants to know if y is a function of x. And it gives you x is equal to y squared. So I have to solve for y. So if I solve for y, I would have to take the square root of both sides. And because I'm taking the square root of both sides, I have to have plus and minus. So now I have y is equal to plus or minus the square root of x. And as I said to you before, because it is plus and minus, this is the reason why this is not a function of x. Because each x is going to give you 2 y values. And I use that as an example because I said, okay, so let's assume that x is equal to, let's say, 9, right? Then if I plug that in, I get y equals plus or minus square root of 9. That means y is equal to plus or minus 3. So x is equal to this, y is equal to this. That means I get 2 points. 9 comma positive 3 and 9 comma negative 3. And since the x repeats, these two draw a vertical line, which fails the vertical line test. Okay? So that's why it's not a function of x. So again, just solve for y, and if you get 2 answers, then it's not a function of x. All right, so number 10 now? Okay, number 10. So number 10 is to find domain. All right, and it says find it for f plus g. So f of x is equal to 4x over x minus 8, and g of x is equal to 6 over x plus 2. Okay, so f plus g just means to find. So all this means is to take f of x and plus g of x. So that's going to equal to 4x over x minus 8 plus 6 over x plus 2. Again, I don't need to simplify this at all. I just need to find the domain. All right? So if I look at this fraction here, right, the only thing that's going to make this denominator 0 is if x was equal to 8. So therefore, my restriction says that I cannot have 8. And this one right here tells me that x cannot be -2, because if it was -2, it would make that denominator 0. So here's the two things that I cannot have. So if that's the case, let's draw the number line. Okay. And let's draw the solution. There's my domain. Okay, so domain. Except, let me do here -2 and 8. Okay, so it's telling me I can have anything but these 2 points right there. So that means this is going to be an open circle, and this is going to be an open circle. So that is my domain. It's in the purple, okay? So that means my domain is going to be -infinity, comma, -2, union, -2 to 8. Again, not including union with 8 to positive infinity. Actually, let me do this. I was trying to do this on purpose, but didn't come out on purpose that way. Union, -2 to 8, and union, 8 to positive infinity. There we go. All right? So that would be my domain right there. Because the only two values I can't have is -2 and 8. Because when -2 happens, this fraction becomes 0. So if that fraction is undefined, you add anything to it, it's still undefined. You take that. What makes that bottom 0? The denominator is 0 and 8 is equal to 8. So 8x cannot equal to 8. Because if this denominator was 0, that means this fraction will be undefined. So this fraction, this undefined fraction plus anything else is just going to be undefined. Okay? So that's why that is my domain. Number 11, I'm guessing? Yep. All right. That one's done. Now to the lab work. What did I say? Number 11. Okay, 11. Okay, so I need to find if this function is even, odd, or neither. Okay, so it's giving me f of x is equal to x to the 5th minus x to the 4th. Okay, so for it to be even, it says that f of -x would equal to f of x. Okay, in other words, if I plug in -x in for x, right, I should get the original back. However, if it's odd, that means f of -x would equal to the negative f of x. Okay, let me write that one better. Would equal to the negative f of x. So I got to figure out what this is, and I told you guys that's what you should write, so I got to find negative f of x. Well, that's easy. Just take f of x, negate everything. So it'll be negative x to the 5th plus x to the 4th. Okay? All right, so now I want to take this f of x. Actually, sorry. I want to find f of negative x, right? If it looks exactly the same as the original, then it's going to be even. If it looks exactly the same as the negative f of x, then it's odd. If it doesn't look like either one of them, it'd be neither. So let's plug it in. So let's actually make this right here. Let's make it purple. Okay? So I got this to the 5th minus this to the 4th. So what do I have here? I said purple, so this is negative x and negative x. Okay. Well, negative x to the 5th is going to equal to just a negative x to the 5th. minus negative x to the fourth is actually going to become positive x to the fourth. However, that minus is there. So that means I still have a negative x to the fifth minus x to the fourth. Does this look like the original? No. So this does not look like f of x, which is x to the fifth minus x to the fourth. This also does not look like negative f of x, which is equal to negative x to the fifth plus x to the fourth. So therefore, this is going to be neither even nor odd. There we go. All right, to number 12. Nope. All right, so this wants to find the domain. Of the composite F composite G, and f of x is equal to 10 over x plus 10, and the g of x is equal to 10 over x. Okay, so in other words, I gotta put g of x into f of x. So f of g of x is going to equal to f of 10 over x. So that's going to equal to 10 over x plus 10. Okay? So a couple of things here. How do I want to do this here? Well, two things. Because if you look at it, there's actually two denominators, right? So I'm going to do it this way. There's two denominators. So the first denominator is the whole thing, right? So I can sit here and say the whole denominator, the 10 over x plus 10, cannot equal to 0, because that would be the whole denominator, so that would make that whole fraction undefined. Okay? The second denominator is here, which tells me that x cannot equal to 0. Okay? So because if x is equal to 0, then 10 over x would be undefined, so adding 10 to it doesn't really matter. It's still undefined. Okay? And then the 10 over x plus 10 also cannot equal to 0, because that's, again, the whole denominator. So that can't equal to 0. So both of these have to be taken care of. All right? So I already took care of the red part. All right? So what I'm going to do now is take this part here and do something with this. All right? So how do I find the x? So plus 10 cannot equal to 0. So let's solve for x. Right? So I got 10 over x is equal to negative 10, because I bring it over to the other side. Multiply both sides by x. So I got 10 is equal to negative 10x. That means x cannot equal to negative 1. So there you go. Those are my two things I cannot have. Okay, so I can't be 0 and it can't be negative 1. So therefore, let's write down the number line. There's a number line. And I have 0 and negative 1. The solution, we'll put down red. Now let's go purple. No, purple. So here's the solution, or the domain, I should say. All right, so this is the domain. And I can't have this part nor that part, right? So those two parts right there are going to be open circles, because those are two I cannot have, okay? So now I would write the domain, and that's going to be negative infinity to negative 1, union with negative 1 to 0, union with 0 to infinity. And there is my domain. All right. Next. All right, where am I now? 13. Number 13. So 13 says, find the domain. Of f composite g. And f of x is square root of x. G of x is 4x plus 8. So I gotta find f of g of x, which means that this is gonna be f of 4x plus 8. So this is going to equal to the square root of 4x plus 8. So this is just a radical, no fractions. So that means 4x plus 8 has to be greater than or equal to 0, right? So that means I got to solve for this. 4x is greater than or equal to negative 8. So x has to be greater than or equal to negative 2. So that would be my domain. X has to be greater than or equal to negative 2. So therefore, I got a square bracket, negative 2, and it goes all the way to infinity. There you go. Okie doke. All right. 14. So this one says that g of x is equal to negative 2 f of x. Okay? So if you look at this, this is telling me that I am multiplying negative 2, and I'm going to multiply all the y values by negative 2. Okay? So this is the lab work 5, number 7, which is that wacky graph. So if you go in, you're going to see some points on there. So my f of x has negative 6, negative 4. It has negative 4, 2. It has negative 1, 1. And it has 6, 6. Okay, so now I gotta find g of x, which is equal to negative 2 times f of x. Okay, so essentially what's going to happen is I'm going to multiply the y values by negative 2. So this is going to be negative 6 comma negative 2 times negative 4. So that's going to give me a negative 6 comma 8. This is going to give me a negative 4, negative 2 times 2, which is going to give me the point negative 4, negative 4. This is going to be negative 1, negative 2 times 1, which is going to be negative 1 comma negative 2. This is going to be 6 comma negative 2 times 6, which is going to be 6 comma negative 12. So right here are my new points that I can plot and figure out which graph it is. So this would be my answer. There we go. There we go. So you just plot those points and it's all done. All right, to number 15. That one's done. That one's done. That one's done. That one's done. Okay. So 15 is on lab work 6. Lab work 6, number 1 says f of x is equal to x plus 4 when or if x is less than 1 and negative 1 if x is greater than or equal to 1. Wow, that looked... Okay, so this is what I would do. So first of all, I look at it this way. This gives me an equation, y equals x plus 4. And this gives me an equation, y equals negative 1. Okay, so let's do that. I'm going to go insert, file, and there's a graph paper. Okay, so there we go. Let's make this a little bit bigger. All right, so let me move this over here. So I can graph these two. All right, so the red line, well, first of all, let's go with the y equals negative 1. So one of the things I said to you guys is that you don't have to remember if this is vertical or horizontal because you could just plot 2 points where the y value is negative 1. Just pick any x values, 0 and 2, right? So 0, negative 1, 2, negative 1. Awesome, so there is my line. It's a horizontal line. It's a horrible horizontal line that I just drew. There we go. So there's my horizontal line, okay? My red line says that my y-intercept is 0, 4, and my slope is equal to 1. So 0, 4, and my slope is 1. So up 1, right 1. So there goes my graph there. There. Okay. So there we go. All right. So now, here is how this gets played out. So the red line only exists when x is less than 1. Actually, you know what? Let's deal with the blue line. So the blue line only exists when x is greater than 1, but including 1. So we look at the x, right? The x is 1 right here. Oops. Undo. All right. So the x is equal to 1 right here. Okay? And it includes it, right? So that means when x is equal to 1, it's part of that blue line. So I'm going to put a big blue dot right there. So anything less is going to be gone. So that means DC's gone. Okay? Gone. Gone. Whoa. Gone. Yeah, it's hard to erase that part right there. Actually, let me do this really quick. Let me move this. Come on. All right, let's move this out of the way so I can erase the rest of this and then put that red line back where it was supposed to be. There we go. All right, so there we go. So the blue line is all set, okay? 0 is greater than or equal to 1. Everything to the right of that is hunky-dory. Okay? Now, with the red line is anything less than 1, okay? And not including 1. So that means at 1, I gotta get rid of, all right? Let's get rid of just a little bit more. Hello? There we go. And then this is going to be an open circle. So that's all it's saying, okay? So it's going to be red line, all the way from negative infinity all the way to 1, but not including 1. Once it hits 1, it starts at the blue line, and then continues on all the way to positive infinity. So whatever line that is the line that you want to pick for number 15. Well, my number 15 or your lab work 6, number 1. Number 2, number 3, number 5, number 6, number 7. Number 8, number 9. Wow, the only one that you didn't ask is number 4 and number 10. So I'm doing 80% of your lab work. Awesome. Okay. So number 16. Again, I can just grade on your neatness. So number 16, it gave you a graph, and it looks something like this. You know what? Let me do this again. Insert file. Let me put in the graph here. There it is. Make this bigger. Okay, so the graph that you see here looks something like this. It crosses -2, -2. It crosses, it's got a dot at -1, 2. It's got a point at 1, 2. And it's got a point at 3, -1. And then it goes up. Okay, so from there to there, there's a line. From there to there, there's a line. And from there to there, it's gonna go to 5, 1. Okay, 5, 1. There we go. And then this rest of this part here is gonna look something like this. Okay, so that is the graph you have here as it goes. Okay, so it's asking you which interval or intervals that it is increasing. Okay, so increasing means it's going up when you go from left to right. Okay, so let's take a look. So here it's going up. So this interval right here is increasing. And when it's asking about interval, it's asking about the x values. So from -2 to -1, it is increasing. So this interval right here is going to be from -2 to -1. Oh, I'm sorry. These are always open intervals. Sorry. It's going to be from -2 to -1. That's increasing. And then it flatlines. This is constant because it doesn't go up nor down. This part right here is going down. I'll use a different color here so it doesn't look so wacky. Let's use purple. It's going down. And then it's going up again. Okay? And then I'm guessing since this goes off the graph that there's an arrow right here. So in other words, from 3 on. So now I have to say union 3 to infinity. It's going upward. Okay, so that would be where it will be increasing. Increasing just means going up. All right, and you're always going from left to right, just like when we're graphing, knowing what's a positive slope and a negative slope. Same idea. Okay. All right, 17. Another difference quotient. This says that f of x is equal to 1 over 2x. Again, the difference quotient says f of x plus h minus f of x all over h. So I need to find f of x plus h, which is equal to 1 over 2 times x plus h. Okay, so let's plug it in. So if I plug it in, it'd be 1 over 2 times x plus h minus 1 over 2x all over h. All right, so essentially what I have to do is saying, again, this is a complex fraction. So I got to ask, what do they have that I don't have? So this one is missing an x, and this is missing an x plus h. Okay, so from there, if you notice that the bottom has 2x and x plus h, 2x and x plus h. So the bottom's the same, so I can combine the top. So top is going to be x minus x plus h over 2x times x plus h all over h. Well, the top, I have to distribute this negative through. So I have here x minus h over 2x times x plus h all over h. Okay. So notice that x, positive x and negative x, crosses each other out. Okay, so I'm left with negative h over 2x times x plus h all over h. So what does that mean? That means I can copy, change, flip. So in other words, I would copy the top fraction, change the division to multiplication, and flip the h. And h is just going to be what? 1 over h. And notice right now is that the h and the h will cancel. So the top, I'm left with a negative 1 over 2x times x plus h. And that would be my answer. Okay. All right. Number 18. Says it wants to find the average rate of change and all average rate of changes is just asking for the slope. And slope is y2 minus y1 over x2 minus x1. Okay, so your f of x here is equal to 5x plus 7. So you have two x's. You got x1, which is equal to negative 1, and you have x2, which is equal to 0. All right, so find f of negative 1. Okay, so that's equal to 5 times negative 1 plus 7. So 5 times negative 1 is negative 5 plus 7 is 2. So I have f of negative 1 is equal to 2. Well, that gives me a point, doesn't it? That gives me the point negative 1 comma 2. Okay, so now I go and find f of 0. Well, that's equal to 5 times 0 plus 7. All right, so what does that give me? So f of 0 is equal to 7, which gives me a point of 0 comma 7. So you're saying that my slope, or my average rate of change, is 7 minus 2 over 0 minus a negative 1. So that means m is equal to 5 over 1, which is just 5. So there is my average rate of change. Number 19. Number 19 says to indicate the operation. So it wants f minus g of x, which f of x is equal to 6x minus 4, and g of x is equal to 8x minus 8. Minus 9. There we go. So it wants me to subtract. Okay, so it just tells me to take f of x minus g of x. All right, so you know what? Let's do this. Let's call this red, and let's call this red. There we go. All right, so f of x is 6x minus 4 minus 8x minus 9. So I got 6x minus 4 minus 8x plus 9. Okay, this is 8. So, like terms, I have a negative 2x plus 5. So this is going to be f minus g of x. And there is my answer. Number 20. And it wants me to find the inverse of a graph. So this graph says it's f of x is equal to x minus 5 squared when x is greater than or equal to 5. Okie dokie. So this base is x squared. Okay, so base, or the parent function, I should call it. So the parent function is y equals x squared, except I slid to the right 5 times. Okay? So if you look at the choices, all of them looks like a parabola, except it says when x is greater than 5, greater than or equal to 5. So in other words, if I use 5, it would be 5 minus 5, which is 0, squared, which is 0. So I know that if I use 5, so let's even just make a table here, okay? So if I use 5, so I can only use 5, 6, 7, and so on. I can't use 4, okay? So if I put in 5 in there, here, let me even do it this way. Let's make it even better. Okay, so let's do this. And I'm not saying that you have to do this on yours. I'm just trying to show you that this is not as hard as you think it might be. And we'll call it x, y, and this is the x minus 5 squared. So if I use 5, then I have a 5 minus 5 squared, which is going to give me 0. If I use 6, then I have 6 minus 5 squared, which gives me 1, because it would be 1 squared, right? If I use 7, it would be 7 minus 5 squared. 5 minus 5 is 2, squared is 4, right? 8 would be what? 8 minus 5 squared, which would be 9, and so on. So I can't use anything less than 5 because it gave me this criteria right here, okay? So great. So if you look at it, it's gonna either be A or C. All right, so with that being said, so again, my f of x has these points: 5, 0, 6, 1, 7, 4, 8, 9, right? Okay, so you're saying, okay, so how do I find the inverse? So f negative 1 of x, well, inverse is what? Switch the x and y. Okay, so this would be 0, 5, 1, 6, 4, 7, 9, 8. Plot those points and you'll find your answer. All right, and you'll also find your domain and ranges as well. All right, so number 21. 21 says it wants to do the composite. So f dot g of x, where f of x is equal to 4 over x minus 6, and g of x is 4 over 3x. So I gotta find f of g of x. So I gotta plug in g of x into f of x. So that means this is gonna be f of 4 over 3x, so which is equal to 4 over 3x minus 6. So he just wants me to simplify. Awesome. So I'm going to say that this 6 right here is actually 6 over 1. Okay. So what do they have that I don't have? I don't have a 3x here and a 3x here. This is still a complex fraction. So with that being said, I'll have a 4 over 4 minus 6, oh, no, not 6, 18x all over 3x, okay? So now I can copy, change, and flip. So I got 3x over 4 minus 18x. Multiply straight across, I get 12x over 4 minus 18x. And that will be one of the choices. And yes, it can be simplified more, but the choice is already there, so therefore there's my pick. Okay? All right, number 22. 22 wants me to find the domain. Wow. Of the composite, f composite g of x. All right, so f of x is equal to 4 over x plus 7, and g of x is equal to x plus 2. All right, so I got to do f of g of x, which means that is f of x plus 2, 2, which means it is 4 over x plus 2 plus 7. So I have a 4 over x plus 9. All right. So I have a fraction. What happens with a fraction? So fraction, denominator cannot be 0. Okay, so I'm going to take this, the x plus 9. So the x plus 9 cannot equal to 0. So in other words, x cannot equal to negative 9 because negative 9 will make that denominator 0. So again, if I use a number line, so I probably should do this and select that part and call it grain. Yeah, there we go. All right. So now over here I have a negative 9. So let's say that my solution or my domain is in green. And it says that I cannot have negative 9. So this will be an open circle here, but I can have everything else. Okay, so that means my domain is negative infinity to negative 9, but not including negative 9, union with negative 9, not including 9, negative 9, to positive infinity. And there is my domain. And there you go. All right, so 22 problems later, and everything else is done. And literally 80% of your lab work 6 is done as well. Well, I hope this helped. Hopefully this recorded, so I'll have to do a third time, or a fourth time, or a fifth time. But good luck.